Hi, Valerie. This is Professor Rick. It's good to hear from you. I loved your email. It's very well worded, and it's really important for all of us to read this. Let's go over it a little bit at a time, and we'll address some of these issues. It says that, I'll start down here, and it reads that it says you have done countless trials with different volume in order to attain the direction. That's great. I'm glad to hear that. Thank you so much for doing this work. It was noted that the volume of reactants calculated by the Precipitation Helper was way too low to attain the desired reaction. So you say way too low, not just too low, so that means that there's something really off here, and that's great. What I would like to know is, here's a question for you. How do you know that it's what tells you, I believe you, what tells you that it's too low? So, and I need to know what kind of information you have that I don't have to help me do this better. And it reads here, based on the experiments done and results obtained, the findings, I think you mean findings, are described in the attached table. The attached table is right here. Okay, I'll put that over to the side. And it reads that you originally had 200 milliliters and you used 1 gram of each, and then you had a result with no precipitation when you looked at what to do, and then you had 200 milliliters of waste, and the reactants you put in were 6.2 grams, and I'm guessing you got these, so you just derived this reaction, you just sort of worked this out and got this. Now weight 1 gram is definitely less than 6, so there's a problem. And then as you go to 500 milliliters, it would say, oh, you only had 2 grams, but you put in to 10, and otherwise you said, oh, these are doubling here on the left, and so these should have doubled to 13.4. I see what you're saying. And you got no reaction, no precipitation here and here, so it looks like it took a lot more just by experimenting with it. Well, I think what we really need to do, the thing that's missing here, is we need to know how much GTC is in there in the first place. That's a big part of what's missing here, because I agree that a gram doesn't sound like a lot. Now, I did take your 38 grams. It reads 38 grams of precipitate here. Now, it can't really be 38. That would be a lot. That's 38 grams per liter, or 3.8%. It could be that much, but if that's wet, it's probably more like 20 grams per liter. But let's take a look at what that math means here, and just take a quick look at something. I'll give you some insight into how this is done. So, for example, if you had, can you see this screen here? If you had 40 grams of GTC waste in your, sorry, not 40 grams of GTC, 40 grams of copper thiocyanate. I'll take a look here. So if you had 40 grams of the copper thiocyanate, which is the precipitate, right? Then you said that is 162, or actually, not 162, 122. It's 122 grams of the precipitate for 1 mole of the precipitate times 1 mole of the precipitate. It's a nice easy ratio. And the reaction is with 1 mole of GTC. That's how we get it. Then we say that the 1 mole of the GTC is 118 grams of GTC. And it's almost the same, so because these aren't very different, right? So that cancels that, that cancels that, that cancels that. And if you this times this and a little bit less, it's like, it'll be a little bit smaller. It's like 30, it's like 38 about grams of GTC per liter. So we're saying that the waste is 38 grams, or 3.8%. Now, if that's true, then 38 grams per each liter of GTC is equal to, that's divided by 118, it's about 0.33 moles per liter of GTC. Now that reaction just happens to be a 1-to-1 molar ratio for both the copper sulfate and the sodium thiosulfate. Whoops. There we go. And so we are going to say that if you have this many moles of that, you have this many moles of each one of these. That's going to be, for every liter of solution, it would mean you would have, let's see, this one is 169, 168. So this is 84 grams per liter, and this is, sorry, this one's 85 grams per liter. And this is 84 grams per liter. So that would mean, like, if you really have 40 grams per liter of precipitate coming out of this thing, then that means you have, oops, I'll put this back here. I'll take both of them. That means that you have a need of a lot of stuff. You would have to put 85 grams of each thing in solution. So that's a lot. And we need to know how much we have. So the precipitation helper works like this. Let's go back and find the page for it. It works like, whoops, that's not mouse. Where is it? Here it is, precipitation helper. It says, hey, how much did you put in, how many grams did you put in until it stops turning red, right? And let's say that it was 1 for 1 liter, right? And if it really is 40 grams, so if it's 40 grams of, I'll go back and delete that stuff. If you had 40 grams of GTC per liter, if you really did, you would require to put in there, divided by 118 grams per mole GTC times 1 mole GTC is 1 mole iron chloride times 1 mole iron chloride is 162 grams. You would have to put in 162 divided by 118 equals times 40. You'd have to put in 55 grams. Like we said, we already figured that out. You'd have to put in 55 grams of the copper sulfate if it really has 38 grams per mole in a 1 liter solution. Now, that's obviously too much, so we use less of it in just determining the amount. So basically, if you were to take 100 milliliters, you should have to put in, let's say, if that's true, you would have to put in 1/10 of that, or 5.5 grams, and the precipitation helper would then predict that you would need 8 grams of copper sulfate and 8 grams of sodium thiosulfate. But if you had 0.200, it would put, and you would say that would be 11. So it would say 16. So if it really is that much, the precipitation helper would be working. So it would be plenty, in fact. So what we really need, what we're missing here, the link we're missing, is an accurate representation of the concentration of the GTC when you start. If you don't have a good analytical method for doing that, then what you're going to have to do is put in an excess of both the copper sulfate and the thiocyanate, meaning that, let's say it's 50 grams per liter. I would suggest you do something like this. Something like put in, take 200 milliliters of the solution and put in something like, let's say, I would say 30 grams of each, right? A lot, too much. And then filter it, dry it, and weigh it. So filter the precipitate, dry the precipitate out in the outside of it or something, and then weigh it on a scale and give me the grams. Back from that, and then we'll try to change the precipitation helper so that it gives you a more accurate result. I really appreciate your comments and your compliments too, and it's good to hear from you guys. Take care. Bye-bye.